Lesson 3 Atomic construction of matter. The atom, what's mean by atom? It's a fundamental building unit of matter that usually can't exist freely. And what are the properties of atom? Don't usually exist freely, don't carry the properties of matter. Atoms of the same element are similar. Atoms of different The chemical symbols of some atoms or elements like oxygen O, hydrogen H capital, carbon C, potassium K, nitrogen N, iodine I, sulfur S, fluorine F, and other elements which consist of two letters. The first letter write in capital and the second write in small. Sodium Na, calcium Ca, magnesium Mg, M capital and G small, aluminum Al, iron Fe, copper Cu, mercury Hg, chloride Cl. If the symbol is formed of one letter, it will be capital. And if the symbol is formed of two letters, the first letter is capital and the second is small. Okay, let's talk about the construction of the atom. The atom consists of nucleus and electron. So the atom consists of two main parts, which are nucleus and electrons. As you see in this picture, nucleus is in the center of the atom and the electrons revolve or rotate around it. Again, so the atom consists of nucleus and electrons. Okay, let's talk first about the nucleus. The center of the atom contains positive protons and neutral neutrons. Positive proton and neutral neutrons. Give reasons. The nucleus is positively charged. Why the nucleus is positively charged? Because the nucleus contains positive protons and neutral neutrons. Because the nucleus contains positive proton and neutral neutrons. Neutral, it means uncharged or zero charge. So the total charge is positive charge. Okay, number 2, electrons. They are minute or very small bodies with negative charge. They are very small or tiny or minute bodies with negative charge. They revolve around the nucleus with very high speed in orbits, known as energy level. So electrons revolve around the nucleus in orbits known as energy levels. The mass of electron is very, very small if it is compared with the masses of proton and neutrons. The mass of electron is very small if it is compared with the masses of proton and neutrons. So proton and neutrons have large mass compared with electrons. Give reason. The atom is electrically neutral. Neutral, we said it means positive equal negative. So the total charge is neutral, it means uncharged or zero charge. Okay, because the number of positive proton inside nucleus is equal to the number of negative electron that revolve around the nucleus. Again, number of positive equals the number of negative. Okay, the positive here is proton and the proton inside the nucleus. So the number of positive proton inside nucleus is equal to the number of negative electron which revolve around the nucleus. The mass of the atom is concentrated in the nucleus. The mass of the atom is concentrated in the nucleus. Okay, because the mass of electrons that revolve around the nucleus is very small if it is compared to the mass of proton and neutrons inside the nucleus. Because the mass of electron which revolve around the nucleus is very small if it is compared to the mass of protons and neutrons inside the nucleus. Okay, let's make a comparison between the constituents of the atom, proton, neutron, and electron. Number 1, position. Proton and the neutrons are in the nucleus. Electron revolve or rotate around the nucleus in energy level. Charge of proton is positive, neutron neutral, electron negative charge. Mass, proton and the neutrons have greater mass than electron. Electron have very small if it is compared with proton and neutron mass. Okay, let's talk about energy level. Okay, electron moves in energy level. So what's mean by energy level? They are imaginary regions, orbits or shells. Regions, shells, orbits, okay, in which electrons move according to their energy. So energy level, they are imaginary orbits, imaginary shells, okay, in which electrons move according to their energies. Okay, so they have different energies. Each energy level has its own energy. Each energy level has its own energy. Their maximum number is 7. Okay, the atom which has 7 energy level will be heavy. So in the heaviest atom, the maximum number is 7. They are arranged as follows: K, L, M, N, O, P, Q. Okay, K take number 1, L number 2, and so on till Q number 7. Okay, and they are arranged from K to Q. The nearest level to the nucleus is K. The farthest level is Q. Okay, the lowest energy level, okay, in energy is K. The highest energy is level Q. Okay. Each energy level can take a definite number of electrons. So, how can we calculate the number of electrons in each energy level? This is a rule for this. So, number of electrons which saturate or fill the energy level can be calculated from the rule X equal to N power 2. X equal to N power 2. This rule is valid only for the first 4 energy levels. K, L, M, and N. N here represents the number of the energy level. 2N power 2. N represents the number of energy level. So we can calculate the number of electrons in each level by replacing N with the number of energy level. Okay, as the following: K to N power 2. K level take number 1. So 2 times 1 power 2 equal 2 electrons. L to N power 2. N here equal 2. So 2 times 2 power 2 equal 8 electrons. M 2 times N power 2. N here is equal 3 because M is the third energy level. So the number of electrons will be 18. And the last level, apply the rule, is N. Okay, and the number of N energy level is 4. So the rule 2N power 2 equal 2 times 4 power 2 equal 32 electrons. Again, so the rule 2N power 2 is applied or valid only for the first 4 energy level. In any atom, the outermost energy level can't take more than 8 electrons, except K can take more than 2. In any atom, the outermost energy level can take more than 8, except K can't take more than 2. The electron does not leave its energy level in normal condition. So, when the electron moves to another energy level, if the atom gain or lose an amount of energy. If it lose amount of energy, it will travel or move to another energy level. If it gain amount of energy, it will move to a higher energy level.